This video will be talking about electrolytes, which are solutions that conduct electricity. Now there's basically three classes of electrolytes. One is a strong electrolyte, which conducts electricity very well. And that's because it has a lot of charge carriers. Remember, electricity is just movement of charge through a wire or other substance. Weak electrolytes, which is a very weak conduction of electricity because there's not that many charge carriers. And then, of course, there's non-electrolytes where it does not conduct electricity at all because what is in the solution is not charged, and so it can't carry current. Okay, so we're going to consider each example and talk about the chemistry in particular. So one class of substances that are strong electrolytes are soluble salts. And so sodium chloride, solid, dissolves in water to become 100% sodium ions aqueous and chloride ions aqueous. Okay? Now notice that what's in the solid is just the two ions, and what is in the solution is just the two ions, and it's a one-way arrow. That is to say, basically any amount of salt you put into water will dissolve up to some reasonable limit. Hydrogen chloride gas, okay, so if you take HCl as a gas and dissolve it in water, then you get something called hydronium, or H plus aqueous, okay? And this is one of the definitions of an acid, something that dissolves in water and produces H plus in aqueous solution. Now this is a 100% reaction as well. So basically, this is a covalent bond, but when you put it in water, it turns out water will hydrate this very polar bond into two ions, where the electronegative element will be an anion, and the electropositive element, which will be the hydrogen, will be H plus. Now one clue that you have acids is, first of all, these are two nonmetals, and the H is written first in the formula. All right, so these are strong, these conduct electricity very strongly because they produce a lot of ions that conduct the electricity. Now HF is a weak electrolyte because it is an acid, but it does not go and dissolve very much. Okay, so if we get hydrofluoric acid dissolved in water, then that produces some H plus and some fluoride, but only about 1% of them. So this has 100 times less ions than a typical strong acid would have. So this is about 99%. So what that means is the HF molecule is polar, so it will dissolve in water, but the bond does not break very easily. And so when it dissolves in water, about 1% of them at any one time have broken the bond. Now what happens is the ions recombine to form the bond, so that's why I've drawn two arrows here. Okay, so whenever the bond breaks, it forms ions. Eventually those two ions will find another partner to reform the bond, and this just keeps going back and forth. Now calcium phosphate is a weak electrolyte because it does not dissolve very well in water, so it's slightly soluble. And so any salt that's slightly soluble only dissolves a few ions, whereas the rest of it just stays in the solid. And of course, the less soluble ionic material is, the fewer ions that will be produced in solution, the less electricity it will conduct. Okay, so the last class of things that actually dissolve in water but don't produce ions are molecules that can hydrogen bond with water. Okay, and so the sugars are a great example of this. So sugar dissolves in water, but it doesn't fall apart into ions. Okay, it stays intact as a molecule, but it has all of these OH bonds that can hydrogen bond with water's OH bonds through hydrogen bonding. Okay, and so the water can be either a hydrogen bond donor or acceptor, and this can be either a donor or acceptor. So that's why sugar dissolves in water very well. Now, I've drawn the hydroxides here, on this ring here. It turns out that where the hydroxides are will give you the different sugars. So there's many, many of the class of sugars called hexoses, and they're called hexose because they have 6 carbons. There's a lot of pentoses where they have 5 carbons and so on. The most important pentoses, of course, are the sugars that make up RNA and DNA. And that sugar is called ribose, and then there's deoxyribose. That's the DNA sugar. But anyhow, that's, so this is very much like water as far as its hydrogen bonding ability, so it dissolves great in water. Now, nonpolar materials, of course, won't dissolve in water at all, so we won't even call them anything. All right, that's it for electrolytes. Okay, da-da-da, done. It'd be funny if I got that right by accident. All right. All righty. All right. Hey, hey. He should be, but I don't see him right now. So I need to stop. Hey, I want to stop on this camera. Can't see anything.
The NX cam.
Yeah, do you know where the stop button is?
Just hit